Hi, I'm Tushar. I have just arrived like around 3-4 months back. I was in Nepal, so I've just been here for like 4-5 months in Brisbane. I have been my whole life since I started. I've been an entrepreneur, more of a hardware and full stack guy. So developing a lot in hardware and a lot of web and everywhere around. So a lot of journey into different tech perspective of different avenues of technology, and now here I am, and let's see how it goes.
Good luck. Thank you, Tushar. Enjoy.
Okay, thank you so much. So let me start this today. I'm Tushar, and I'm talking about IoT. So IoT has been a very buzzing term few years back. It was as big as AI, but somehow it lost itself, and AI is in every conference, and IoT is the minority. So there are many things that IoT promised, many things that we thought it will bring, but we are lagging behind. Let's see how we will overcome. So this session I'll be talking about Google's Cloud IoT Core, the product that Google used and developed for the development of IoT. It had multiple features, and how we did a small project or business of my own, and how the business got hampered by the closure of Google IoT Core, what challenges we faced, and how we overcome. So all of these things is my own story, so it will revolve around that. So yeah, after the closure of Google IoT Core, we did have a serious trust issues with Google and other companies. So let's talk about that. So I came from Kathmandu. Kathmandu is a cultural city. It's around 2,000 years old. Old temples, small roads, very hard to travel around. And this cultural significance of the city, we as a small business entrepreneur, we can see that the city is growing. It is now 1.4 million people, but in a very clamped, small roads, worse public transport, and a lot of other issues. So we were trying to solve a public transport problem, and a client approached us. So what they did was, they wanted a simple, very simple project. They wanted us to build a vehicle tracking system that was able to announce the next stop. It was a challenge in Kathmandu because of the hills and mountains and everything. So, and the clamped small roads. So it was a new project. It was back in like 2017 something. So it was a huge revolution for the public transport system back then. And a client really, they came to us and they approached us. So the requirement was very simple. A GPS tracking system that has an announcement system. There were some speakers, the LED lights showing like this station is coming, that is doing. So this sort of small system that our client asked us to build, and like we thought like, okay, this is not that big of a project, so let's do it. I mean, we could do it. It was like, we thought it was a very easy project, a small project, nothing hard to do. I'll tell you a little bit about myself. We have been at that time developing a new Arduino clone. Arduino is a IoT-based hardware. It was once hackers, go to device, like everyone used to have one of those. And we built our own version, own flavor of it, and we called it Neupaney. We're like from Nepal. So yeah. So that's what we did. Everyone was doing this, putting the Arduino name behind it, and then using whatever. So we did this. We did a lot of other stuff. Started to work on this, and we were very enthusiastic. When the transport company came to us, we thought like, okay, this is our project. We know how to do it. We'll put in Arduino. It will send GPS. We have everything planned. Once the client came to us like, we need a GPS tracking device. I know what to do. I mean, we knew what we do, right? So that's how we started. Pretty easy, we know what to do. And what we did was, because we were like a sort of a hardware enthusiast, we removed everything from Arduino and used the direct Atmega 3228P. That's the processor, that's the SoC inside the Arduino. So we just used the SoC, removed all the components, and start building every component that we required. So remove part of it, try to make it cheaper. So what we wanted to do was, like, because when you are a hardware developer, there are two main things that gives you goosebumps. One is you are using very small amount of data to communicate. Another, your processing time is very fast, like 2 seconds faster. That's what we love. And and we use hardware or system that is minimal as possible. If you don't need it, don't use it. That's what hardware developers basically they love. So we only use the Atmega 3228P processor, the microcontroller, and we removed everything else. A little bit of challenges. We built a hardware system. We put a GPS system on it. We put a GSM module on it. We put a speaker on it. We put a LED display on it. We put things like that, and a temperature control and things like that. So we packed a hardware and put it on a bus. So the public transport, and up there was a globe box we're putting there. So that's basically, this was the configuration, a simple, and the GPS tracker, the LED lights, a heat sensor, GSM. Nothing much, just pretty small project. It works. I mean, we did it in our office. It works, Yeah, then what happened? We take it to the road. And what happened? The signal is lost, no signal. There is a huge amount of heat. We have never thought that if you put a device in a glove box, it could fry. So that was happening. The GPS was giving us weird signals. It was simply flying over the houses, One signal here, one signal there, and the road was like flying over the houses. It feels like the bus is traveling on the air, That was happening. Not enough memory. The Arduino was quickly running out of memory, because what was happening is the GPS was was not enough data, or sometimes what is happening, part of the data is hanged and the GPS won't be responsive. Then what happens? Arduino will stop, will like wait for the GPS to send them signal and wait forever. And it was like a disaster. This is a pothole. We never thought that a pothole, what happens is that our device, we just made it like we soldered it, made it perfect. In a pothole, slowly, every time it hits the pothole, the whole device was coming out. We never thought that. I mean, it works in our office. I mean, it works everywhere. The internet is perfect, the GPS is perfect, like everything works. And it's a pretty simple project, I mean, yep. And the last one, obviously. Yeah. So and then we went like, at first, when we met the client, we were so confident, we convinced the client so well that we started the project. We were telling them that our device is working fine, it's working 100%, and it was flying in places, it was shutting down, it was off for like 3 to 4 hours. I mean, to reset a device, we have to find the bus where it is traveling and then locate it, stop it. There were passengers in the bus, get in the bus and then reset it. And we have to explain the client that we are pretty close, we have done it. We're like, there's some very small problems, like we'll fix it. That was embarrassing, Like, for us, technically it was like a pretty small, like 2 or 3 problems, like we could fix. But then for the client, it was like disaster. Nothing was working. I mean, we were the worst thing was happening to us, right? So we started to fix it. I'll tell you about like how do we fix it with the prediction part. So with the heat, we put our fan and we change the location. So we somehow controlled it, right? With the pothole part, we actually built a single board. Like we had multiple components. So we removed that, made a bigger board with fill it, and did it a little bit. Easiest part. And now what we did is that we wanted the Arduino to use as much less computation as possible. So we moved massive part of computation to the server. Yeah, to the server. So what the server has to do is the server has to wait for all the signals, interpret the signals, interpret GPS data, interpret everything. Arduino was just like a relay system that was like getting all the data from the hardware and simply sending it back to the server, receiving the information from the server and acting as well. So we're pretty much like solved that part of the problem. So it was working. The prediction part I'll tell you a little bit later. So for the server side, what we did was we used Google's Cloud IoT Core as an entry point where all our Arduinos started to send data using a protocol called MQTT. So it was sending all the data through MQTT to Google Cloud IoT Core. Then the Google Cloud IoT Core was connected to PubSub service, which is another message broker, which would then send all the data to BigQuery, which is a table, and then a cloud function. This is like, I'll tell you what we did with the cloud function. Then we use a data studio dashboard for the clients to see. So technically, we built a lot of software part of our system using this architecture and reduced a lot of work, like made our life a lot easier. Google Cloud IoT Core has few more features, had few more features, what it was doing was, it was able to identify what device was sending it data, and also it was able to update our devices, like it was able to update the ROM of our devices from the server. That is so much of work that, for example, if I have to update the ROM of a Arduino, like out of like hundreds of devices, it would physically require a lot of work. You have to go and get the bus and try change it, do whatever. So all of this was reduced. The work was reduced due to Google Cloud IoT Core. It was remotely able to update the device, which was amazing. And that service and many other services was like so much good for us. It was like one thing kill all, So we had this architecture and it was working. And in the cloud function, where I told you earlier that we have done some mapping work. So how we did was, the green dot that you can see here, this is the GPS coordinate our device was sending. So literally it was like flying all over everywhere. So what Google's map API did was, it mapped this trace to an actual road. So when we show it to a client, so the bus was now traveling in a road. Yeah? So this trick actually saved a lot of our work. We were having a lot of GSM data failure, we were having a lot of GPS issues, and this was single-handedly solved a lot of our issues for the clients. So this snap to roads is a API inside Maps API from Google. So this is what we use, and it solved a lot of our problems. Now we have another problem. So it's a very small project, so bear with me. Let us assume that there is just 1 kilobyte of data per second being sent from a hardware device. One kilobyte is not much data. We were sending everything. We were like dumping all the logs, we were trying to get as much data as possible from the device. It was like, for a small setup, it was like amazing. All the data was coming. We were able to identify small problems. But when we were able to sell a lot of devices, like in 2020, we were able to sell 300 devices, we had to actually calculate how much data we were bringing on. So if we just like say 1 kilobyte per second, we were doing it like in an hour, 3600 kilobyte, in a week, this is 600 MB, and for all the devices it was 180 GB per week. Now this was big. This was big in many sense because we're only sending coordinates. So only coordinates, 180 GB of data, and now imagine searching something, doing some analysis on it. I mean, and that's just a week. I mean, that's the volume of the data. It's a small project, but now it turned into a huge nightmare, you know, like all of the data. The clients didn't care, but we had an issue, you know. So this was huge. So we tried to do as much as we can. So what we did was we tried to narrow down the amount of data we have to send, doing a lot of work on it. Like for example, what we did was Nepal is a rectangular country, more like a rectangle. Yes, what we do is that there is not much of a change in latitude and longitude, right? So we could clip part of the latitude and longitude and not send it to the server. So we'll still understand it's inside Nepal, you know, because the vehicle is not going to be outside the country. So we were assuming a lot of data so that we were able to send less data to the server and still be correct, right? We were also using only 4-digit device ID. 4-digit device ID means 9,999 number of devices, right? So what happens if we sell 10,000 devices? From 10,000 devices, we'll have 1 extra byte. But up to 10,000 devices, we still have just 4 digits to store. So that's how we were trying to like solve it as much as we can. And a lot of other, we stopped sending dumping all the log data and everything. So we were trying to be very, very selective. Even we omitted the day and month and year from the date, you know, because it was like, we started to assume that's from today. And time, the problem is that we have to send second and minute because of the lag of data reaching the server and all that. So server's time and our device's time was different. So that is why we had to store second, hour, minute. But after that, we were all assuming it. So there were places where we were like playing a little bit, you know. So that's how we reduced significantly. We did cut all the ASs, and we reduced it like to 70 bytes per second from 1 kilobyte. Because we're dumping too much data, we just removed a lot of data. We removed temperature, we removed a lot of other we came down to 70 bytes per second. Again, we thought like sending 70 bytes a second is not necessary. So we started to send 70 bytes of data every 2 seconds. So cutting the data by half. And then also, because the vehicle will be in standby, it started working just for 8 hours. So when the GPS coordinate of the device is not changing for a while, the device will stop sending data. So that means we're still cutting down on data, you know? And that means it's 8 hours, 70 bytes, 60 minutes, 30 seconds, that's 1 MB per day. And if it's, so it's like 2 GB per week. But then what we did was, we also knew that only 40% of the time, all the vehicles were running. So it's like, some of the vehicles were like in a garage, somewhere else. All of them are not running, only 40% of them are running, if we could calculate all of that. So based on that, based on the 40% assumption, it's only 800 MB data per week. So we reduce significantly from GBs of data to MB of data. So that's how we like cut corner everywhere, you know? So now the cost factor, obviously. So Google Cloud IoT Core, pretty cheap, 0.11. Google Cloud PubSub, BigQuery, 25.2 MB is per month data uses to all our devices. And then all of the cost per devices, and then total cost for like one device is just $2 a month. So the data charges was just $2 a month. And life was amazing. Like everything was fixed, everything was working. Google Core IoT, amazing, everything amazing. Then Google's Core IoT was retired. You know, when everything working, and we had to do a lot of struggle to reach there, and Google suddenly stopped it. And we were like, we could have assumed anything, any disaster, but Google closing down on something, you know, I mean, yeah.
Well, how much notice did they give you?
Well, yes, they did give notice, but we never thought, we never looked at it. We assumed it. You know, yeah, I mean, I have to be genuine, you know, because, yeah, I mean, and why were you using Google Core IoT? Like, it's secure, it was using public-private key with JWT, it was like supposed MQTT, which is like hard, very easy for it. It was remote management, so you know which device ID is running, which is sending, whatever happening, all that data. It's also part of it was part of the ecosystem. Like, we were using Google Core IoT and we were building every other app inside Google. So it is part of the ecosystem. And also reliable? No, it was not. And you know the funniest part? Google Core IoT literally suggested us to use Amazon in their website. Literally, that we are sorting down, go to Amazon. And what we did, now we stopped trusting Amazon too. We trusted nobody. We set up an Nginx proxy server. The proxy was what it was doing. IP that all the information that our device was sending, it was sending to the proxy server, Nginx server, and Nginx will redirect to any IP that we want to. So next time, if everything Google shut down or Amazon shut down, we'll just simply change Nginx. Yeah. We just change the IP address now. This time, go there. You know, just that's what we did. We trusted nobody. So that's how things happen. But then we thought, like, okay, we went to Amazon, but like we were too frustrated. We were like, not even, you know, we were like, let's go to Amazon. Like, Google is shutting down Core IoT. Let's go to Amazon. We dropped everything, moved to Amazon. I can tell you how we moved to Amazon, but that will be in Amazon's workshop somewhere in like their office, not here. So yeah, so here, what happens is that, so we're looking for options Google. So was there an option that we could still remain in Google and be functional, you know? So what could have been done? The first thing that came to all our mind was to replace Google Core IoT with an MQTT source, and that's an Eclipse MQTT server. Download it, put it somewhere, Google Cloud Compute, and everything works, right?
What is MQTT in acronym?
MQTT is a message broker. I forgot the full form of that. It's like it's a POP-sub service, you know. So so it's MQTT is a POP-sub service. Yeah, it's a message broking service. So we thought of this one, yeah, Eclipse MQTT, and that could have been an option. We put everything into perspective. We put MQTT into like Google Compute Engine, and look what happened. The cost from $2 went to $7.35 if we use that. The compute engine is pretty costly, and Google was giving us, Google Core IoT was better. And another thing was that Google Core IoT also had other features like updates, additional services. This was like not included because there is no alternative. So the price is not included here. So then we thought, like, okay, MQTT, but there is already a PubSub service, like Google PubSub is already a PubSub service. Why don't we directly communicate with Google PubSub? What if Arduino directly communicates with Google PubSub and remove Core IoT? Like, if we are only replacing TT part of it, then just remove that part and directly communicate with Google PubSub. Well, that was okay. That's okay because that's almost the same thing. But the problem is more of a, like, you know, the services that IoT was giving. It was not just an MQTT server. It was an MQTT server plus plus. You know, there was like a lot of other things that we care more. So we did a change of structure. So we started to work on a compute engine to host a website that would just give us a detail of which device is sending the data. So not exact replication of the whole of Google Compute, Google Core IoT service, but it was enough. And also, in the persistent disks, we have stored some firmware. So what happens is, if there is any changes in the firmware, any update that is required, the MQTT server would actually update, will tell the device that there is an update available, and it will simply download it through an HTTP channel, the ROM, and write it, burn it, okay? So that was possible now. So this all was possible, but we had to do some additional changes. We had to use SSL certificates, we had to use, and there's also a network charges in Google, but there's a cap, so it's like 1 GB network is free for a month, and so there's a cap, but then still there's network charges, which I have like eliminated. So now, with additional setup, we went to like 7.75. So all of that, because we have to add now hard disks, we have to add other features, you know. So the charges went from $2 to $7.75, right? And for a small business, I mean, Google did this to us, you know. Google did us ugly, yeah? Yeah. So how did everything work? So we set up a proxy system. So we could make a switch to any architecture when required. That's like we could switch to Amazon, we could switch to Azure, we could switch to Google, like any architecture. Proxy was the first step. Second step was on middleware, now the website, and, which was hosted in a Google Compute Engine. So it was a droplet, it's a website. So the droplet could now be changed to any other platform when and where required. So even that was modular. So we were like, we have huge trust issues. So we started to trust nobody. So that's how we moved forward after we had an issue with Cloud IoT Core, right? So we started to think like we had this new understanding that when you are building a product, like when you are trying to build a product to the customer, you must understand that you must not be relying to anybody. That the whole structure should be modular and everything should be replaceable, everything should be upgradable, and you are relying to no individual provider at any time. So that was what we learned the hard way. So this is basically the structure that we had, the proxy server that will send data to both the PubSub and the device manager, and then the persistent disk through which the updates and everything would happen. The PubSub would give data to the BigQuery, from which the Cloud Functions would start to communicate and update the BigQuery, which Data Studio will use the data to visualize it. Slowly, right now, like we have also replaced Data Studio with our own visual dashboard. So that part is also done, but that's like, it's the Data Studio is still was free, so the cost was not changing. So that's what we did. So thank you. Thank you, Google.
I'm sorry, Tushar. I was so interested in your talk, I completely forgot I was meant to be emceeing. That's how you know it's a good talk. Give him another clap. I had a quick question. Is the project still going, and how many buses is it still running on? What's happening now?
We started with public buses, but it's more popular with, now it's more popular with this, what is earth-moving trucks, big trucks.
Okay.
Yeah.
The freight trucks.
Yeah. The one which like has this bricks and motors and everything, that earth-moving trucks.
Yeah.
Yeah. So these sort of trucks, so it's still going and it's doing good.
That's excellent. That's really good to hear.